In this video lecture, I will discuss about a very short topic, hexagonal closed pack structure, and this is very important for your coming exam. Okay, so first we would like to find out what are the lattice parameters of hexagonal closed pack structure. Here only we will focus on the two lattice parameters. First, we would like to find out number of atoms per unit cell, and second, what is the atomic packing fraction for the hexagonal closed pack structure. So let's try to find out the number of atoms per unit cell, and before that let's see what is the unit cell for the hexagonal closed pack structure. So here you can easily find out that these atoms are arranged in this way in HCP structure, and we can easily find out its conventional unit cell is of structure hexagon, right? So we can write the unit cell is hexagonal, and you can easily find out A, B, C, D, E, F. It is a regular hexagon, and which is nothing but the unit cell for this structure. So first we would like to find out what is the area of unit cell. So if you observe carefully, you can find out in this unit cell there are six triangle. One triangle is clearly given here. This is O, E, A. You can make the second triangle, third triangle, fourth triangle, fifth triangle, and the sixth triangle. So this unit cell is made up of six triangle, right? So what is the area of this unit cell? So we can write area of this unit cell is 6 into area of a single triangle, right? Okay, very good. Sorry, 1 minute. So first we have to find out what is the area of this single triangle. Then if we multiply with 6, we can get the area of this unit cell. So let's try to find out what is the area of this single triangle. So here we have taken separately this single triangle and drawn here. This is OFA, this is the triangle, and then since this triangle is an isoscale triangle, so its angle will be 60 degree, 60 degree and 60 degree, right? Because it is a part of a regular hexagon, so these angles are 60 degree. Now what is the distance between FA? This distance is 2r. Why 2r? Dekho, if you just observe carefully, you will find that this FA distance is nothing but the center to center distance. If we think the radius of one atom is r, so then this distance is r and another distance is again r. So this FA distance is 2r. Similarly, what is FO distance? It is also center to center distance. So again this is also 2r. So what is the area of this triangle? Area of this triangle we can easily have this 2r into height h. We don't know what is the h, so let's try to find out it is the h. So for that we will consider this triangle. This is angle of 60 degree and it is a right angle triangle. So from that we can easily find out what is the sine 60 degree. It is h by 2r, and from there we can find what is the h. H is equal to 2r into sine 60 degree. So it is 2r into root 3 by 2. So basically we find out this is root 3r. So this h is nothing but this is root 3r. Okay. So what is the area? So area is half into 2r into root 3r. So this is basically root 3r square. So area of what? Area of the single triangle. But what is the area of this whole unit cell? This unit cell is made up of 6 triangle. So we can just multiply 6 into root 3 r square. This is the area of whole or complete triangle. Okay. Now, what is the number of atoms per unit cell? We would like to find out the first this lattice parameter. Here you can find out that each atom share its some part, that much part is shared within this unit cell. So how much part is this? Okay, so there are 6 atom. This atom share certain part of its to this unit cell. So we have to find out how much is this sharing. Okay, so first in this unit cell this atom is completely shared within this unit cell, so we have taken 1. but there are 6 atoms and certain part of each atom is shared by this unit to this unit cell. Okay, so let's try to find out how much sharing is there. If you observe carefully, you can find easily that each atom, that much part is shared. So what is this angle? This angle, if you observe carefully, it is very easy to find out. This angle is 120 degree. So from the complete atom, there are 120 degree angular part is shared within this unit cell. What is the complete angle of this atom? It is 360 degree. So we can find out the part of the atom, it is 120 degree by 360 degree, this is 1/3. So 1/3 part of each atom is shared within this unit cell. So let's try to find out. So then what is the number of atoms per unit cell? Then it is easy, that is the single atom, complete atom, and 6 into 1/3. So number of atoms per unit cell is 3. It is very important. Now we would like to find out what is the atomic packing fraction. Atomic packing fraction. So atomic packing fraction for this 2-dimensional case, you would like to find out that area covered by the number of atoms per unit cell divided by area of unit cell. Because it is 2-dimensional, that's why we have taken this area, otherwise we have to take the volume. So area covered by the number of atoms per unit cell divided by area of the unit cell. So what is the area covered by the number of atoms per unit cell? So number of atoms per unit cell is 3. If the area of the single atom is pi r square, so then the numerator should be 3 pi r square. And what is the area of the unit cell? We have just find out, it is 6 root 3 r square. Okay, so then we will use these two things and easily we can get what is the atomic packing fraction. So area of one atom is pi r square. So total area occupied by atoms, there are number of atoms per unit cell is 3. So then it is 3 pi r square. What is the area of unit cell? 6 root 3 r square. Hence the atomic packing fraction 3 pi r square by 6 root 3 r square. It is pi by 2 root 3. It is 0.91, that is 91%. So this is very important for your ESA. Here I would like to also focus what we have discussed throughout this semester about your coming ESA. I would like to summarize here. You have to focus on solid state physics, that is the crystallography, crystal structure. And in crystal structure there are cubic system, there are 7 other crystal systems, lattice parameters we have discussed. And in cubic system, basically simple cubic, BCC and FCC structure we have discussed lots. You have to find out all the lattice parameters, that is the number of atoms per unit cell, atomic packing fraction, coordination number for all these 3 structures. Then very important part is Bragg's law of X-ray diffraction, and from the Bragg's law of X-ray diffraction there are several numericals. Then move to the Miller indices. Miller indices for planes and Miller indices for direction. It may be asked in your question paper, draw the Miller indices for different planes. For example, there is 100 plane, 110, but for different planes you have to draw different unit cell, and in different, for example for 100, this is the 100 plane, but don't show 110 in the same figure. For 110 you have to draw the separate figure. Okay, in this way. And there is at last we have discussed also about the interplanar spacing. D is equal to a by root over a square plus k square plus l square. This is for the cubic system, and from that formula there may be also some numericals, so be prepared for that also. And at last, this atomic packing fraction and the number of atoms per unit cell for HCP structure, it is very important. So that's all for coming ESA. Best wishes from my side, and I would like to stop here.